let's answer a couple of questions related to that exercise that we just saw. So how much did the buyers end up paying? Well, they started off paying $14 before the tax. After the tax, they pay $16. So they've ended up paying an extra $2 because of the tax. This might be surprising to some of you guys. The price didn't go up by $6 when we added a $6 tax, because some of the tax got eaten, if you like, by the sellers. What happened to the price the sellers receive? Well, it was $14 before, right? And now it's only $10. And the sellers end up receiving less than they did before. But in total, the tax has been divided in some way between the buyer and the seller. The buyer pays $2 out of the tax, the seller pays $4 out of the tax. A third question, and this is a pretty important one for analysing the effect of this tax, is how much money did the government collect? So for that, we just need to know two things: the amount of the tax, like how much the tax was per unit sold, and how many units were sold. Well, we know the equilibrium quantity is 50,000, and there was $6 as a tax. So our tax revenue then is $6 times 50,000 gives us 300,000 in tax revenue. Another little place you can get tripped up here is, before you do this exercise, you might say, oh, there's a $6 tax and the quantity traded is 60,000, so we're going to get $6 times 60,000 is 360,000. This would be wrong because that tax ends up reducing the number of trades that take place. Now we can go ahead and show this tax revenue on our diagram here. This is part of why we like shifting that supply curve up by the $6 amount. Now that difference between the supply and demand curves at the quantity of 50,000 and the $50,000 length outline this rectangle here. And as we've seen previously, an area on the graph represents a particular dollar amount. In this case, we've got the height of this rectangle is $6, the length is 50,000, multiply those two dimensions together and we get the amount of the tax revenue, the area of this rectangle, at 300,000.